welcome to the end of week 6. No surprise that our mini project for this week is Blackjack. Blackjack is a card game that's played in Las Vegas and many other places where people gamble. You can also just play it for fun. The rules for Blackjack aren't too difficult. We talked about them a little bit earlier in this week. What I'm going to do in this lecture is I'm going to walk you through a couple of trickier programming issues you have to actually work through to implement Blackjack. I'll show you both the program template and a demo of my implementation of Blackjack and say a little bit more about what you should do for this particular project. And then I'll finish it off. Scott and I will have a little bit of fun. Okay, see you in a sec. Okay, let's talk about how to compute the value of a hand in Blackjack. So just to review, if you recall, the value of a card in Blackjack, well, it depends on what kind of card it is. Let's see. For a number card has value equal to the number. So the 3 of clubs has value 3. Let's see, for a face card, okay, what is that? That's a king, a queen, or a jack. That has value 10. So the other thing that's really tricky is an ace has value 1 or 11. And notice this is the player's choice. So the tricky part of kind of computing the value of a blackjack hand is dealing with the fact that an ace can have one of 2 values. So what I'm going to do is I'm going to show you kind of a simple method for determining the value of a blackjack hand. It's not going to require any kind of complicated logic. So let's move that up. And let's start a new block here. And so what we need to do now is we need to compute the value of a blackjack hand. So there's going to be a key observation we're going to use here that's going to make it fairly simple. So if you remember this, you're in good shape. And that is, if you have no aces, well, okay, no big deal. And you don't have to worry about 1 or 11. If you have 1 or more aces, you have to kind of figure out how many of those you should count as 11. I mean, you can always count them as 1 and kind of keep your hand value as small as possible to avoid busting, but you'd really like to kind of count kind of at least 1 ace as maybe 11 or maybe even 2 aces. But the critical thing to observe here is that if you try to count 2 aces as 11, you have 22 points and you've busted. So really the key observation here is that you would never count 2 aces, let's capitalize that, aces as 11. So that actually leads us to our algorithm for how to compute a hand value. So here's our algorithm. So let's let hand value be the sum of the card values with aces as 1. So just go out there, let's compute up the value of the hand counting aces as 1. And now we're going to have to do a little bit of logic. So what we could say is if the hand has no aces, what do? We could just say return hand value. That's easy enough. Of course, the question is what happens if we have an ace? Remember, the worst we're going to do is we're going to count 1 ace as 11. We're not going to count 2 aces as 11. So the logic we need to do is the following. You just say, what happens if we counted 1 of those aces as 11? That would increase the value of the hand by 10. And if it doesn't bust, we should probably do that. So we could say, else if hand value plus 10 is less than or equal to 21, what do? Well, we go through and we return hand value plus 10. Else, what do? We return hand value. So that has the nice property that when we're computing the value of the hand, we kind of always give it the maximum value possible. Now that doesn't bind the player. The player can make decisions based on kind of whether they want count aces or not. The critical thing here is when the dealer's evaluating this hand. This always has the property that if a dealer has an ace, he counts it as 11 unless, of course, it makes him bust. So this is really designed to compute the value of the dealer's hand correctly. Okay, let's go on now and I'll talk about a second issue having to deal with how to actually deal cards to the dealer's hand after the players stood. See you in a sec. Okay, the second programming issue that may require a little bit of thought is building some Python code that repeatedly hits the dealer's hand after the player is stood. So when the player stands, if the player's hand's not busted, then the dealer needs to hit their hand until their value of their hand is 17 or more. So to do that, we're going to have to use a while loop. So in fact, no place else in this course are we going to use while loops. One of the kind of beautiful things about event-driven programming is that you don't really need a lot of complicated looping constructs for simple programs. But for this program, we're going to need to use a while loop. So let me kind of give you the logic, then we'll talk about how you do this in Python. So the logic is pretty simple. I want to say something like while the value of the dealer's hand is less than 17, what do I need to do? I need to hit the dealer's hand. So how would I turn that into Python? Well, let's see. In Python we have the while loop, and it looks something like this. It's while test colon execute the body. So the way this works is, as we execute a while loop, we check the test. If the test is true, we execute the body. Then we execute the test. If it's true, we execute the body. Just keep doing that until finally the test evaluates to false, in which case we skip the body and proceed on to the code after the while loop. So how would we do this inside Blackjack? Well, we would just go through and use a while statement, and we would have to do two things. We'd probably have to use the get value method inside the test. And what else? We'd probably need to use the hit method for a hand inside the body. So I should say here the get value method for a hand. So that's really it. It's not very complicated. One thing to be careful about is when you build loops, if you don't do the test correctly, you can get an infinite loop where the loop just runs over and over and over. So some of you probably wondered why sometimes you get a timeout error inside Code Sculptor. We put basically kind of a timer in there that keeps track of how long your program is running in one block of code. If it takes more than about 5 seconds, we actually stop the program because there's nothing you should be doing that's going to cause it to run for 5 seconds solid. Everything we're doing in this class is fairly simple. And that's designed so your browser won't hang and just basically cause everything to collapse. So if you're sitting there and you're running your code and you're getting timeout errors, check the condition in your while loop. Make certain that you've got it done correctly. Once you've got the dealer's hand to be 17 or better, if he's busted, the dealer loses. If the value is less than or equal to 21, you compare the dealer's value to the player's value. The bigger hand wins. And finally, remember, the dealer wins ties. This is the way we're going to do it for our particular version. In Vegas, there are other versions, but for our version, dealer wins ties. Okay, let's go look at the template and demo. Okay, let's take a look at the program template for Blackjack and then kind of take a quick look at a demo for Blackjack. So I've got it loaded here into Code Sculptor. We provided you with kind of two images. One is a tiled image for the deck of cards. That's what we saw in the previous lecture. I've also provided you with an image for a card back. We have some extra data here, the suits and the ranks organized by the tile image. We have a dictionary that converts strings corresponding to cards into values. Most importantly, we have a card class, which we've implemented for you. We have a hand class. Most everything has passed in here. Your job is to implement those methods. We have a deck class, which again, you'll need to implement. Remember, for shuffle, you're going to use random.shuffle to shuffle. There's a little bit of logic that you're going to have to keep track of inside Blackjack. We have a global variable called in play that kind of tells you whether the hand is actually over or not. That's important to know because you'll need to know whether to display the dealer's whole card or not. And you have some event handlers for the various buttons, hit and stand. And let's see, I think I set this up so that the draw handler is actually drawing a card for you just to get you started here. So take a look at the code. This is kind of a good piece of code to get you started on doing it. Let's go on and look at a demo of my version of this. So we'll pull this down here, and what I see is got the canvas up here. It's green. I've got Blackjack written here. I have a score. I have a display of the dealer's hands and the player's hands, and I have a message. The message is going to kind of prompt me for whatever I need to do as somebody who's playing blackjack. So right now I have 7. The dealer's showing 10. Ask me whether I want to hit or stand. Well, I definitely want to hit. So now I have 17. It's very likely if I hit again, I go bust, so I'm going to stand. At that point, the dealer's whole card is exposed, and we see the dealer had 20. I lost. My score is now -1. We hit a deal, play, deal again. I have 14, not very good. What the heck will hit? So I went bust. My hand value was 22. The hand was over. The dealer's hand's exposed. He had 20. Let's see if I can do better. So right now I have 20. That's very nice. The dealer's showing an ace. It could be 1 or 11. Let's just go ahead and stand. The dealer had 21. So notice I didn't recognize blackjack immediately. This version of game we're building is a simplified version of blackjack. It's not going to have all the bells and whistles you see in Las Vegas. So please stick to the rules as described in the mini project description. Let's try to do one more where I can win. So I have 19. That looks good. We're going to stand. The dealer hits, goes from 12 to 17. It's then forced to stand. So I have 19, dealer has 17. I win. Yay. Let me say a little bit about when you're building the project. You're welcome to use your own card images. Make sure they load and run. Please stick with the basic rules of blackjack as we've described them here. No doubling down, no splitting, no dealer and player push. Keep it very simple. If you want to go through and actually build something more interesting, feel free to take the scoring system here and, for example, add in something that modifies bets or not. You can keep track of chips for the player and the dealer. I think that's reasonable. Basically, there's one rubric item corresponding to scoring. I've asked everybody to score very generously on this. So if you want to riff on the turned-in version, riff on the images you use, and riff on how you do the scoring. But don't modify the basic rules of blackjack. It's just going to make it too hard to peer assess. You're welcome to turn in something that's very, very fancy inside the peer feedback thread in the Hall of Fame. Okay, so let's finish this up now. I think Scott and I have one more piece of business to attend to. Don't run off.
All right, in honor of this week's mini project, Joe and I have decided to place a high-stakes game of blackjack for you here to just get you in the mood. And since we're not going to bet money, what we're going to bet is a tie. Okay, so if I win, then Joe will wear a tie in one of the videos next week. If Joe wins, I will not wear a tie in one of the videos next week. Okay, and for this, I'm going to be the dealer. We're going to play best 2 out of 3. All right, and let's get started here. All right, looking good for me already.
All right. Lucky for me, I have my handy-dandy card-counting cheat sheet here, which every person in Las Vegas is supposed to have. So let me see. It's a 12 versus an 8. Oh, it says you lose. No, it says hit. Okay, well, the sheet says hit. I better hit.
All right.
Oh, okay, I now have, let's see, 4, 8, 6, 18. I have a feeling I know what that's going to say. Yeah, I have to stand. All right, I stand.
All right, you ready?
17. Oh, yeah! Oh, yeah, by the way, David's always forced to stand on 12, 17. All right, 1-0 me. Now, see, I can count cards, too, actually, here. So what does this say? It says, okay, you have... okay, all right, good, all right.
All right, good luck with that counting.
Wait a second.
Hey,
they're not supposed to shuffle?
The project says you have to shuffle.
No, that's the project.
Hey, we're playing by the rules of the project.
That's not fair now. Oh, okay, there we go. There we go. You need a 6. Oh, God. All right, time to go back to the sheet. Sheet says 15 versus a 2. It says to stand. Well, the sheet could hardly be wrong.
All right. Okay,
It's got a
12.
Oh, yes! Yes!
All right.
Oh, this is the revenge is sweet.
You're going to be seeing an unprecedented video next week.
All right, that was fun.